In this problem, we're selling fancy iPod earphones, and we know a little bit about the process. We are told that the price-demand equation is given as a linear function, where P is the price and X is the number of earphones that will be sold at that price. We are asked to determine the price that will maximize the revenue. And when I see a problem like this, the first thing I key in on is that they're asking me to maximize or minimize something, in this case maximize. And the thing I need to maximize is the revenue. This tells me that what I should be after here is a function for the revenue. We can use whatever letters we like to represent this, but I'm going to use R for revenue, and I'm going to let X be the quantity that's varying in here. My goal, again, when I'm finding a maximum, is to try and find the maximum point, the highest value that the revenue function in this case attains. And I want to find the price from that. Now, where this becomes the maximum may not in itself be the price, so I have a piece of this problem I'm going to need to return to. But in the beginning, find the revenue function, and then figure out how to find where the maximum value of that function is on some domain. So we need to think about what revenue is equal to, and although revenue is related to profit and cost, I wasn't given enough information here about profits or costs to try and make use of that. If we drop back to just the basic definition of revenue, revenue is the amount of money you're bringing in, so it's the price times the quantity that you're selling, making and selling. So if I can figure out what the price function is and what the quantity function is, then I can multiply those two together and have the revenue function. And if we reread this, we realize that the price function was given to us. If I am making X iPod earphones, then the price that I'll get for them is 40 minus 1/50th times X. So when X is 1, this would be 40 minus 1/50th. So 1/50th is, what, 2 cents? So it'd be 39.98, something like that. And as X varies, so will the price. So the number of these that you're producing does affect the price. So demand is related here. And then I need to, that's the price function, I need to multiply by the quantity that I'm selling. And the quantity I'm selling is exactly X. That's the number of earphones that will be sold. So X is the quantity function. For some problems we may have to construct something more complicated, but in this case the quantity is what X represents. All right. So in terms of the process here, I need to find the revenue function. I've done that. I now need to find its highest value on the graph. And so you start looking at the revenue function, looking for some structure. And what I see is that the revenue here is a degree 2 polynomial. If I multiply this out, I'll have 40x minus 1/50th x squared. So that's a degree 2 polynomial. Its graph will be a parabola. And I know that the maximum of a parabola occurs at the point that we call the vertex. So I don't need a very accurate sketch of this, but if I can rough this out and find the vertex, then I think I can use that to answer any question that they might be asking. So I will look for the vertex. A couple approaches possible here would be to find the two zeros and graph those, and then the vertex will be halfway in between. Or you could multiply this out and use the formula x equals minus b over 2a for a quadratic. That will work. Or you can multiply it out and use the quadratic formula to find the two zeros and look halfway in between. But in this case, since it's already factored, I can see the two zeros. This quantity will be 0 when x is 0, so the revenue function goes through the origin. And this quantity will be 0, let's see, whenever 40 minus 1/50th x equals 0. This will be 0 if that happens. And so 40 needs to be 1/50th x, or x needs to be 40 times 50, just solving for x, so x will be 2,000. So at 2,000 over here, the function r is 0, and we know it's a downward opening parabola, so this thing must rise and then fall again to hit down at 2,000. There's symmetry here, so halfway in between is the x value for the vertex. So there will be a maximum revenue